Okay, let's give you guys some practice. Try to sketch this line here. Um, yeah, just try and find out which term dominates when x is small around this region here, and which term dominates when x is really big. So you could just visualize this as one block here, but merge these two together because if you merge these two together, it will give you a more accurate answer, and also because you're pretty good at drawing a straight line. So this here, you can see that this has a gradient of -1, and this here has an intercept. So you're pretty good at drawing straight lines anyway. So you might as well merge these two together. Yes, you can just look at it as a 3. So this here, when x is small, you can just visualize it as a straight line. But rather than visualizing it as a straight line, merge the minus x in there. So it gives you something like this. It's a more accurate answer than just looking at 3. Well, anyway, do what you have to do. Try to sketch this line here. Press pause and have a go. Okay, so look at this here. When x is small, it wants to obey this. Okay, it wants to follow this. When x is big, it wants to follow this. So if you look around this region here, if you put 999 into here and 999 into here, this term here would dominate. This term, well, these two, they're nothing in comparison to this term here. You see, 999 to the power of 3 is a really big number. And if you look at around this region here, if you put, say, 0.06 into here, you see, this here will be next to nothing. Whereas if you put it into here and here, in comparison to this here, this is much more important than this. Okay, so overall your graph will look something like this. Hang on. So it will look something like this. When x is small, it wants to follow this. So intercept of -3. So let's guess -3 to be around here. -3, and it's a straight line here with a gradient of -1. So it would be a straight line like this. Now, when x is big, it wants to follow this x to the power of 3. It wants to do this. It wants to do that. But when x is small, we have to follow this when x is small. So hang on, let me start again. So here, when x is small, it wants to follow this. So let's draw this here, -3 here. So it's a negative gradient of 1. And when x is big, it wants to do the x to the power 3 graph. So we're just going to guess something like that. And here it could go over, or it could be under here. Well, we don't know. You need to know calculus in order to find out this point here. But let's just guess it to be like this. So it's similar to this. And again, here, this bit here, we don't know. It's just guesswork, and we need to know calculus in order to find out how far down it goes or how shallow it is. Okay, but for the time being, let's just guess it to be like this. So the moment of truth, let's see what it really looks like. See, so here, remember, this is y equals x to the power 3 minus x minus 3. You see, this is a straight line here. This is actually minus x minus 3. See, a negative gradient of 1 and the intercept of -3. Okay, and then when it's big, it wants to do this. It really wants to do this here. But because it has to compromise with this line here, because when x is in this region here, this part here overtakes this. So you really ignore this bit, and you have to look at this bit when x is small. Remember, when I say x is small, I'm talking about when x is in this region here. Remember, the x is the across here. So from here to here is 2.5. So when x is small, it's around here. Well, anyway, your graph will look something like this. This is the x minus 3 minus x minus 3 here, and this is your x to the power 3. So it's just a matter of joining up the two. Okay, well anyway, it will look like this. Okay,